Hi, this is Mikhail Golovnya, Senior Scientist at Salford Systems. What I'm going to talk about in the next few video segments is a very special battery that belongs on the advanced list of batteries, but it could be extremely useful in a number of applications, and that is the battery target. Now, in some other videos, I already talked about the importance of studying and understanding whether there are certain relationships among your predictors. And we even talked about battery one-off when you check univariate relationships between the target variable and all of the available predictors. Well, now we are going to move it to the more advanced domain and look at the multivariate relationships among predictors. There's a number of different situations when running battery target could be an interesting and adventurous exercise. First of all, you will always get a better understanding of what's going on your predictor side. As statisticians, we often tend to think about variables as being totally independent of each other. Well, the reality is that in most practical applications, this is far from being the case, and variables always end up being dependent upon each other. But more importantly, battery target could become the underlying force to do missing value imputation. And I would say, as far as the importance of battery target overall, it is its implications in terms of providing you with the mechanisms to do effective missing value imputation that makes that battery the most interesting one. So what I'm going to do, I will first introduce battery target just to show how it works and feels. We're not going to cover all of the different options, so I'll just give you the general guidelines of what it is. And then we will see whether we can use it and how we can use it to do missing value imputation. So let's get started. What I have here is a Salford predictive modeler running. And I'm going to introduce a wine quality data set that as our main working data set here. So first, let me open the data set. So I go into Open Data File, Files of type CSV. And I have this wine quality red underscore miss as my main data set. The data set has 1,599 records. And it all has to do with some kind of wine testing. You know, here in California, wine testing is a very popular thing. But apparently this data set comes from Europe. I think these are Portuguese wines. And if you do the view data thing, that what you will see is that there's each line represents a specific wine, and based on some wine tasting experts, each wine was assigned some kind of quality factor. It ranges between 1 and 9, but typically anywhere between 4 and 6. And then you also have all sorts of descriptors like acidity, sugar, alcohol, sulfates, density, pH, all those kind of measurements. Now notice some of these measures are missing for whatever reason, and I did it just in order to illustrate how missing value imputation can be conducted. But for now, just let's not worry about the missingness, and let's build a simple model that is trying to predict wine quality based on all of those chemical characteristics. So I'm going to model setup here. I'll pick 3-net gradient boosting, one of the sampling engines that we'll use, and it's also one of the powerful engines to do the imputation. Another alternative would be using CART, but I'll just illustrate some of the 3-net parts here. So I'm going to sort in file order. Quality is my target. This is a regression run, so all of the remaining descriptors are my potential predictors. I'll use 20% test sample. And as far as the 3-net goes, just for the sake of simplicity and the speed, let's just build 200 trees. Each tree will be based on 0.1 learn rate. And there are some other things here that are relevant. Now, I proceed by building a very first tree-net model just to quickly highlight what happens in this case. And the model is a regression run, so the accuracy of our predictions is about 31–32% on the test sample. And it can be improved if you reduce learn rate, increase the number of trees, so I'm not going to focus on that side for now. But when you look under summary, variable importance, you'll see that the number one most important variable is naturally alcohol. Well, I guess when you work with these data sets, it's always interesting to see whether your intuition works or doesn't work. But again, maybe it's most important, but we don't really know how exactly it influences. To answer that question, you just go under display plots, open univariate dependency plots, click on alcohol, and now you can see, it's actually having this kind of relationship, and it's general rising. So as the percent alcohol increases, the subjected quality of wine kind of improves. And you can look at all of the remaining ones, like acidity is another factor, and acidity has the opposite trend, and so on and so forth. So in any case, I'm not going to study some of the intricacies of wine tasting here, so let me click on the summary and focus for now on this list of important variables. Now, these are all of my predictors, and as I said, in the conventional statistics, you usually would assume that they're all independent. In reality, let's actually see whether that claim is correct or not. What I'm going to do next is, in order to test multivariate dependencies among my predictors, I will ask SPM to do a very special battery where for each individual round, it will take one variable at a time, use it as a current target, and then use all of the remaining predictors as predictors for that specific model. So, for example, the first model will use alcohol and all of the remaining variables as my predictors. The second model will use acidity and then all of the remaining variables as my predictors, and so on and so forth. So the battery target essentially takes the existing list of predictors and then rotates individual variable on that list and then builds the corresponding model using all of the remaining variables. So let's see how this can be done. Go back to model setup. At this point, I don't need my target variable at all. So uncheck this. I'm only focusing on the list of predictors. Then I go under battery and look for the battery target. It might not be available in all of the versions that you have, but the advanced versions of SPM for sure have it. So the brief description here, make each variable in keep list as a target. So I'm going to add this one here. And for our purposes, we don't even have to worry about setting the battery options. In most practical situations, just running at the battery in its default settings will be good enough. Now, all of the remaining settings will be taken as is. So now I click Start. And, okay. Okay. All right. There were all sorts of special cases where the model could not be built, so we're fine with that. And it comes back with a number of models. Notice by default, it attempted to build models for missing value indicators and so on and so forth. We're not interested in those, so I'm going straight into regression models. And what's most interesting here is that if each regression model is measured in terms of R squared, and I can sort it based on my test sample, then you can see that now certain variables on the predictor list can be very naturally predicted with a high degree of accuracy when you look at the corresponding model. So when I double click on this line here, for instance, it opens up a tree-net model. For the model that attempts to predict density based on all of the remaining predictors, and that model has 87% R-squared on the test partition. Now, if you look at the summary, you will see that the variable importance list shows acidity and alcohol and sugar as the most important drivers here, and you can also look at the plots and quickly see that the nature those variables contributing, and it also puts some of the missing values there as well as some of those markers on these plots. So, and that's just the very first variable on the predictor list. The next one is acidity, and again, very nicely predicted. And when you look at the summary, those are the variables that can be used to predict the values of acidity fixed, and so on and so forth. So now we basically found a collection of runs that show how variables on the keep list, on the predictor list, are interconnected. And also notice that sugar and sulfates are one of the lowest prediction accuracy, only 46%. So if I double click on that, then you'll see that you can still do some kind of prediction in that department, again using density, acidity, alcohol, but it's just not as accurate. So definitely sugar and sulfates are a lesser dependency structure than all of the remaining variables. Okay, so as you can see, what we've done at this point is we managed to look at just the list of predictors, and we asked SPM automatically build a collection of individual models that capture mutual dependency among those predictors. Now, where that might be useful in a number of situations. Now, you sometimes may start with a very large number of predictors, and it typically in the real-life data sets out there, some of those will be perfectly dependent on each other. Now, there will be situations when some variables in your data set are binned, some variables in your data sets are transformations of the others, and especially when the data comes from a different client or the data that you never worked with before, running battery target could be very useful because it immediately highlights some of those clear-cut dependencies that you may find. Now, even if you do not find some clear-cut dependencies, that's also an interesting additional piece of information because it really does allow you to see what's going on your predictor side. Now, as you explore battery target, you'll see there are some options that allow you to select missing value indicators as potential additions to the list of the models, or whether they're allowed to be used as predictors, and so on and so forth. And those are just some additional advanced little areas that you can explore and study on your own. So, but as far as running battery target, it's very simple. You select the number of predictors, you pick battery target, you let it run. Sometimes it may complain about some models not being able to complete, which is fine. But then whatever is able to finish is later represented using one nicely packaged screen. So in the next segment, we're going to take this battery target output and use it to do missing value imputation.